Alright guys, welcome back. You might want to check real quick to make sure that you have the book assignment in from last class. It's been a full week. So if you did not put that in Google Classroom, you forgot about it or whatever, your last chance to get full points would be to give me the hard copy right now. So if you need to check that real fast, then please do. I'll give you a second to check that. Give me time to put in attendance. And then I'll tell you what we're doing today and remind you about where we are at in our unit. 2, 3. Okay, so last time I saw you guys, we had started section 1.9. So we reviewed the algebra side of what it means to be an inverse function. And again, I was not in charge of planning this unit, so I'm not really sure why Ms. Thomas split this up over 2 days. when we normally do it in one day. So most years we do the book assignment that you did last class and today's practice quiz all together, and then quiz it the second class. But since she planned it out that way and my 8A classes did it that way, then we will do the same for you guys. So today's work is fairly light here, but the handout that you picked up is number 87. So please go ahead and number that. And since we have the time to treat this as a real practice quiz, what I'm going to do is give you, let's say 30 minutes. I think 30 minutes is way more than enough time to go through that, but go ahead and give it a shot. Without a calculator, without help, without your notes, just answer the questions as you would best do. And then when the 30-minute timer's up, I will go over the whole 87 with you. And then, of course, you can identify what you might need to review. So our quiz for 1.9 will be first thing tomorrow, because this is a B week. So if there is anything you didn't remember from last year and you didn't pick up last Thursday and you still didn't get on this worksheet, then that's a pretty big red flag of something that you need to spend a few minutes on outside of class. And of course, with the quiz, it might be a good idea to set a reminder about it as well, especially if you're the type that likes to look over your notes for a few minutes, because we will do that first thing tomorrow. Quiz will be about the same length as this practice quiz, so it'll only take 20-30 minutes, and then we will move on to the next section after that.
Mr. Hansen, I have a track meet tomorrow.
Okay.
Can I do it next week during advisory?
Sign up for Tuesdays. Well, you'll have to sign up for Wednesday prime time, but I don't have my session set up yet, so we can't do it right now. Tuesday next week is Atlas testing, so there won't be advisory on Tuesday. It'll have to be Wednesday. Again, I don't think this is going to take y'all 30 minutes, but I will wait 30 minutes before I go over it, just so everyone doesn't feel rushed.
I can put this and I turn it in, it's not turning in. I can put it this and I can turn it in, it's not.
Click turn it.
It didn't turn in. So if it's late, that's why I did it before
That
class.
assignment turned in.
Wait, is it going to be kind of late now?
No, I haven't started grading them yet.
Thank you.
But you shouldn't be waiting until last minute.
I turned it in last period.
It was from last week.
I know.
Last period is last minute too.
There's the ACT, and then a few days this week we had games that got us.
ACT was one morning.
Sounds like an excuse. No, then we had
When
games.
you miss class, you get 1 day plus the number of days you miss plus 1. If it's school business, it's considered a planned absence, and you shouldn't be behind at all when you come back. You knew you were going to miss. A week is...
Ooh, bro, you have an absence.
Huh?
That's the Moore Library. It's fine. It started. It's all good.
It's not like you were sick in the hospital and unable to do your work. You could still go home and catch up your work.
You're right. You're right.
Also, since it's been a week here, remember that the reason we are even spending a couple days on this section, well, I mean, it's good algebra stuff to review, and actually my 8A classes said, a few people said that they felt like a question or two on the ACT they took on Tuesday was about inverse functions, which I guess was good for them and maybe not. Well, maybe it was good for y'all too, because we had talked about that. But really the main reason we're doing that is because after our quiz tomorrow, we will spend 1.5 classes on exponential functions, and then we'll spend a couple weeks on logarithmic functions. And logarithms are harder for some people, but logarithms are the inverse of exponential. So once you know what an exponential graph looks like, and you know what it means to be an inverse, you automatically know a little bit about logarithms before we even talk about it together. So that's why we even spend these couple classes on it. All of this is about. These are the handouts I'll get out next class.
Thank you. Oh yeah. I think I'm gonna mix it in this class too.
And of course, you guys need to watch the class recording, teaching us. If you don't want to wait until this class ends tomorrow to start catching that up, you could watch my 8-day class on Monday, I think is when we went over it, so.
Oh, thank you.
Just if that's better for your schedule. Still got about 20 minutes. Again, I know that's a lot, but we've got the time, and I don't want anyone to feel rushed. So you can see where you're really at. Well, I mean, I'll talk about it when I go over it, but do what you would do if this was replaced. Also, these are part of this too. No, you wouldn't focus on. Okay. I will talk about it when we go over it. Okay, just a couple more minutes if you're not finished. Make sure you focus on that, please. Alright, it's been about 30 minutes here, so let's go over so that you guys can check your answers and to make sure you weren't just getting lucky on something. Of course, all of this would be good. Good likely questions to be on your quiz tomorrow. So anything that you missed or you were unsure about, you might want to put a star next to so you remember what to look at. Okay, so inverse functions at their core just means you're swapping input and output. So if you're talking about algebra, you're just swapping x and y. So if you had all of these points on a function or an inverse, you should be able to just swap x and y and have a bunch of points on the other one. So I'm not sure why there's so many points, because if you can do it, you could do it with just a couple, but I guess the only mistake I often see on this is sometimes students will make things negative, like they'll switch them or change the sign on them, but that's not what inverses is about. Inverse just means swap x and y only, not change signs. Alright, to prove or to verify that two functions are inverses of each other, you need to plug them into each other. That is called composition of functions. Plugging a function into another function is a very common thing that you'll see in college algebra and calculus. So on this question, they were nice enough to kind of push you in the right direction. But this one wants us to plug g into f. So you would take g, and everywhere there was an x, you would instead put what g was equal to. Now, the point of this is not, are these inverses, yes or no? The point of this is for you to show or to verify that they're inverses. So you need to show the work here. I can do this arithmetic in my head and see what it simplifies to, but that's not the point of the question. You need to show this one plugged into this one, distribute your 4, undo the minus 12 with the plus 12. You need to show the work that it simplifies to x. And you need to go the other direction. So you need to plug f into g. So instead of 1/4 x plus 3, it's 1/4 f of x plus 3. So I would need to see that. Distribute the 4th, and then undo the minus 3 with the plus 3. That's the only way to prove or verify that they're inverses of each other. Question 3, there can be lots of correct answers to this one. So very likely that you got this correct and did not put the same thing down as me. But I would say A is a little tricky because of this. It says it's a function, and the fact that it's a function means that our picture here must pass the vertical line test. That's what makes it a function. But to not be one-to-one, it's got to either fail the vertical or horizontal line test. So you can come up with whatever you want, but whatever you come up with, better pass the vertical line test, but not the horizontal line test. Other than that, try not to overcomplicate it. Something like x squared passes the vertical line test, but not the horizontal line test. Whereas this question says you want a function, so vertical line test must be passed, and come up with something that's one-to-one. So one-to-one means it passes vertical and horizontal line test. So same thing, anything that passes both of those would be perfectly fine and be acceptable. I would just do something like y equals x, just because it's quick and easy. That passes vertical and horizontal line test. So he is a function that is one-to-one. So once I finish going over this, if you aren't sure if yours would be accepted or not, I'd be happy to look at your paper and give you that clarification. Okay, on to question 4. I took this part off because this wouldn't be on your quiz, so I didn't want you to use those steps. It's just still on mine. So this one says find the inverse of this. So just like question 1, you just swap x and y. Same thing with this. Swap x and y. And then you just need to finish solving this for the new y. So undo the -1 with the +1, and undo the square with the square root. Oops. That's what you were aiming for the inverse. Now, there's a few different things. This stuff goes with question 4 also, and this worksheet's been made up for longer than I've been teaching pre-calculus, so I'm not exactly sure what they were aiming for here. But I have a couple tips for you that will help you, and I think it has to do with this one, and maybe this one too. So, remember visually, this is something you guys should be able to graph. This is just x squared shifted down 1. That would look like this. The first thing about this, though, that should bother you is that this is not one-to-one. It's a function. It's a function, passes the vertical line test, but he doesn't pass the horizontal line test. So as he stands, he doesn't have an inverse function. That is why this is important to be in the question. This is saying, but only keep the part when x is equal to 0 or greater than 0. So mathematically, that's a fancy way to say, let's only look at half of the graph. Let's restrict the domain. Let's only look at this half of the graph. The reason why you might want to take this into consideration, and the reason why you might want to graph this, even though it doesn't say you have to, is you could then graph what you think the inverse is. This would look like the square root of x graph, shifted left 1. And we know that a function and his inverse graphically should have this line of symmetry at y equals x. So if you're willing to graph this part of this function and graph what you think the inverse is, even without a calculator, you should be able to eyeball this and then feel very good about your answer. Or feel bad about your answer and know that you need to retry it. So just a suggestion. Likewise, I think this table is kind of pushing you to also check your work. So this referred to the function. So if I plug 0 into the function, I get -1. If I plug 1 into the function, I get 0. And if I plug 2 into the function, I get 3. And at first, you might be wondering, that seems very random. And I also think it's kind of random. But if you think about what we talked about on question 1, again, I think they're trying to help you see that you can kind of check some of your work. If 0, -1 is supposed to be a point on the function, then -1, 0 is supposed to be a point on the inverse. Since I just found the inverse, I can test to make sure that that's true. If I plug in -1 for x, it does give me 0. If 1, 0 is a point on the function, 0, 1 should be a point on the inverse. So it would be in your interest to go ahead and plug in 0 for x, solve for y, and see that it's 1 like it's supposed to be. And if 2, 3 is a point on the function, then 3, 2 should be a point on the inverse. So again, it's in your interest to plug in 3 for x, solve for y, and see that you get 2. If you know these points are on the function, and you know these points have to be on the inverse, plugging them into the inverse to see that they are actually there is going to further make you feel good about that answer. So that's the only theory I've ever come up with about why that would be there. All right, and then for the domain part, we did not, this might be one of the harder questions on here because we didn't review this in your notes, but we did talk about this last semester. So when I look at this function and think about his domain and range, well, this, when it's restricting the x values that you look at, it's restricting the domain. It's saying just look at these x values. That's its domain. You would have to graph this function to see its range. Bless you. It goes down to -1 and up forever. The reason why that might want to cross your mind is that that can help you with the inverse as well. Because the difference between a function and his inverse is you swap x and y. So that also means you're swapping possible x's with possible y's. The domain of the function becomes the range of the inverse. Possible x's become possible y's. And possible y's are going to become possible x's. And that is the easiest way to know what the domain of the inverse is. Or I guess you could graph this. I encourage you to graph it also, and if you graphed it, I guess you could just look at the graph and see that it's -1 to infinity. But you got a few different options there on how to figure that out. But of course, on your quiz, it wouldn't hurt for you to do it multiple ways and make sure that it's all consistent. Okay, I'm going to keep on going here, but I will give you guys a chance to ask for specific questions after we look at the last few. All right, question 5 is just like question 1. The only difference is question 1 kind of worded it in words, whereas this is using math notation. Here's 3 points on a function. Switch x and y. You've got 3 points on the inverse. Don't change the signs, just switch x and y. I would say from past pre-calc classes, number 6 is probably the one that you guys missed the most. So let's review what you were trying to go for here. Usually I'd say if you miss this is because you gave up a little bit too quickly. But we're supposed to come up with something that's an odd function that does not have an inverse function. So to not have an inverse function means that it has to fail the horizontal line test. So whatever you drew, if it passes the horizontal line test, you didn't do this part of the question. To make it be an odd function, you have to remember a characteristic about odd functions. So let me remind you the difference between even and odd. Even is like x squared, symmetric to the y-axis, whereas odd is like x cubed, and we call it symmetric to the origin, or 180-degree rotation. So you had to think of something that had this type of symmetry, but that did not pass the horizontal line test. So x cubed is odd. It has the right type of symmetry, but it passes the horizontal line test. So again, usually this is about where students will give up a little bit too quickly. But what you can do is you can just add a little bit of a dip on this side, which adds a little bit of a bump on this side. Now it has the right type of symmetry, but his inverse is not a function because it no longer passes the horizontal line test. So that one is possible. You just had to think of something with the right type of symmetry that messes up horizontal line test. All right, and then question 7 is basically vocab. To be a function, it has to pass the vertical line test. If it also passes the horizontal line test, then his inverse is a function. And if it passes both, we call that one-to-one. Okay, so I've got 2 questions for you guys. First off, is there any of these that you want me, that you have a specific question to, or you want me to talk about a little bit more? Again, the quiz doesn't look exactly like this, but this is pretty close to what the quiz looks like. So
we'll cover the not exact same questions, but the same kind of concepts, I guess.
Yeah, similar concept, yeah. Okay, then I am asking that you turn in 87 before we start the quiz next class. So if you have it finished, you might as well go ahead and turn it in the Google Classroom so you don't have to worry about that tomorrow. I think it would be a good idea to spend a couple minutes looking at your notes. 85, any questions you struggle with on the book assignment 86, and maybe any questions you missed on this practice quiz for 87. That's what I would do between now and tomorrow for your quiz. Okay, my other question is, I know a lot of you guys did the ACT last time on Tuesday. Did anybody have any comments or strong feelings about it being easier than normal or harder than normal, or anything in the math that seemed familiar to you?
I think there was one inverse function one on there.
Okay.
33. It was super simple though.
Is this something you would have remembered before we did this?
Kind of.
Okay. I take that as a no. What about trig? Is there much trig on it?
I don't think so. Anybody else? Yeah, there were the triangle ones. I remember. Yeah, a lot of trig. Decent amount of trig actually. There's a lot of like.
There was like sine, cosine, and tangent questions.
Like SOHCAHTOA?
Yeah.
Yeah.
And there was also like the inverse interior angle stuff like that.
Yeah, there was that
With
too.
like the parallel.
Yeah,
line.
parallel.
Okay.
And there's one going-
Alternate interior
Yeah.
and stuff like that, yeah.
Yeah.
Well, unfortunately, I only ever really talked about alternate interior, so if it was one of the other ones, you may not have remembered.
I think it's the one we talked about.
Oh, was it? Okay. That might have just been lucky then. I heard from some of my 8A classes that the compound interest formulas were
Yeah,
one of the
that was in
questions.
there. Uh-huh.
Well, unfortunate for you guys, we didn't quite get to that, but we will actually talk about those tomorrow. So
Didn't they give you the?
my 8A classes had gotten that quick review before the ACT, but.
It did give you the formula on the test though.
Oh, did it? Okay.
Yeah. So you just kind of plug it in and then
Huh.
it didn't really
We
work.
make you memorize the two compound interest formulas, but if they're starting to give it to you on the ACT, maybe I need to talk to Miss Thomas. Maybe we shouldn't stop making y'all memorize it too.
Yeah, that'd be a good idea.
Well, one of them is PERT, and PERT's important, so you really should memorize that one.
Okay. Yeah. Okay.
The other one is a little harder to memorize.
Yeah, I'll put it.
P times 1 plus R over N all to the NT, but
Oh, and there are a few logarithms on there too.
yeah, we'll get to logarithms in a few weeks also.
Logarithms is the hardest thing ever. It's so hard. I hate logarithms.
Well, my guess would be that they probably just had you evaluate on one of them. Something like my computer needs a break.
Question. Can I go turn something into one of my other classes real quick?
Who is it?
Miss Mills.
Where's she at?
One story down, like literally right there. I don't know if you know where Miss Baker's
this?
room is. She's like right next to Miss Baker.
They might be at lunch right now, but yeah, you can take the pass.
I think they have beat lunch. I don't know.
I don't know. I mean, you can go by and try, but if her door's shut, you might have to go back later.
Okay. Just write my name.
Yep. Just put your name on the board till you bring me the pass back. Okay, I would guess that one question on the ACT, if it asked you about logarithms, would be something like this.
Yeah, that and then some, one of them.
Yeah, but this is easy.
27.
No, it's not. I just threw it in the calculator.
27.
And then the other one, they didn't give you the base, but they gave you the
27
answer.
cubed.
Oh yeah, there was one like you said. It was like log x and then
27 or whatever. And they gave you
equals
the answer.
something else.
Okay, equals.
I don't know, 9.
I think it was 9 and 32.
So hard.
But I don't know.
Okay, 9 and what?
32.
Like that?
Yeah, I think so.
Does that even make sense?
It does.
It makes sense, but that answer would be.
You probably have to be done.
I plugged all 4 answers in the calculator.
Okay, if you know how to type a logarithm in a calculator, that's fine.
Yeah.
But this guy just means. This just means 3 to what power gives you 27,
Right.
which is.
No. Or
No, not 3 times.
no,
3. Yeah.
Yeah, so let's say take out the base, like right, the 3 next to the log, and then they put an x there, you gotta find the x or something.
Okay.
Yeah, there was one of those.
So
There's a lot
the
of-
same way that I went from this to this, you can, this is called logarithmic form. You can take the log away, which makes it exponential form if you switch these two things around. And so what to the third power gives you 27?
Complicated.
You definitely did this in Algebra 2.
We did. I wasn't very good at it.
Well,
Okay.
I don't know. I've not taught Algebra 2 in a few years, so I can't say. But when I used to teach Honors Algebra 2, we would do logarithms in 2 weeks, which is just really a brief introduction. We will spend like 2 to 3 weeks just on logarithms after exponentials, so it'll be a lot easier then. Which does not help you for your last ACT, but maybe it'll help you for your next one.
Gotcha.
Okay guys, before I turn the screen off here, again, make sure you give me 87. I will ask for it at the start of the next class in case you forget or you're having trouble with Google Classroom. We will do the quiz next class, the first 20-30 minutes, and then we will move into section 3.1 and talk about some exponential function stuff. So, if y'all see any math questions you'd like to ask while you're here, please go ahead and ask, because you guys do have a good chunk of time, about 45 minutes. So make sure you're prepared for that, and then if you need to work on something for another class afterwards, that would be fine too.